here we have a nice little function about the inverse of trig functions. And so we have the function g, given by g of x equals sine of x minus cosine x, has a period of 2 pi. In order to define the inverse of g, which of the following specifies a restricted domain for g, and provide the rationale for why g is invertible on that domain. And so now, I'm not going to sketch specifically this yet. We're going to go to the calculator for that. But we know that sines and cosines will end up looking like this. And this will, in fact, have a similar shape. It is a function because for any given x value, there is exactly one y value. So if I put in this x value, I get one y value. If I put in this x value, I get one y value. But as a whole, on the real number line, it's not invertible. It does not have a function for an inverse, because for a given y value such as this, there will be infinitely many possible x values that could get me there, and that wouldn't be a function, because when I put in this y value, let's call that y naught, to my function, my inverse function, I would get more than one output. That's the one thing a function has to have. Each input goes to exactly one output. So the trick to it is to cut a portion, the largest portion you can get, that gives me unique x values for each y value. And so I could go from a maximum to a minimum and take these values. That would be an invertible piece of this. I could go from a minimum to a maximum. Notice I'm actually including the minima and maxima here, because even though it becomes horizontal here, it doesn't double up any inputs. It's just for that one value. I could also do something dumb and say, okay, let me go from here to here, here to here, and then here to here. And this would also be an invertible, an interval, a domain that I can cut from there, but it's just not as nice, not as standard. So let's figure out what's going to work for our function. Let's go to the calculator. So let's start by graphing sine x minus cosine x. Let me check to make sure my mode is correct. I am in radians, that's good. So I'll do sine of x minus cosine of x. And I'll change the zoom to standard because I was doing some other stuff here. Okay, so I want to pick these things. Now, I know I'm going from -1 to 1 on the y values. Or I guess, sorry, not -1 to 1. I'm actually going from -√2 to +√2. I guess I might not know that. And I know that I care about things from, let's say, -pi up to 2 pi. That'll cover everything we care about. So let me change this to be -pi up to 2 pi. And then we change the y values from -2 to 2. That's a safe pair of values, safe range to take, because I know that sine and cosine are both bounded between -1 and 1. Okay, so on here, I have a couple of options. My options in this area are to go from here to here, or go from there to there. And let's see what happens. So first off, 0 to pi is a terrible option, because, let's see, 0, let me trace to 0. That's going to be right here. Let's trace to pi. And I can see that I never invert y values down here, and I actually double up. So this, not only will I miss inputs to my inverse function, but I will also have more than one output. So it's not going to be a function, and it doesn't get everything. A is a terrible choice. Let's look at B. So from -pi over 4 to 3 pi over 4. Let's see if that works. Trace negative pi over 4. That looks good. That's my minimum. To 3 pi over 4. And that's my maximum. So that's a possible interval. Let's see if that's a good choice, because all possible values of g of x occur without repeating on this interval. That's exactly right. So I will go from here to there. So that's going to be something like this. I get all of the y values, but I never double them up. This one, also not good, because, so not a function, and we don't hit everything. This one, it doesn't matter that the length is half the period. That's sort of necessary to hit all of them, unless you do something really crazy with non-measurable sets. But this is also half length of the period, and it's not correct. So my answer should be B.